There you go. So my drawer is labeled. It says supplies on it. If you need anything, get it. Vincent. Lunch count. It's open on this screen, but it's so easy to forget about. Thank you, sir. Well, that I can pause. With our warm-up problem here, we're going to check homework in a second, but we want to look at the warm-up problem real quick just because hopefully you were just working on it. Can you what? Sure, I'll take volunteers on this one. So, what did we use? What were we calling this? And then what are we really doing here? When we had the math, and we would like... Yeah, guys, we're making zeros, but really, that is combine like terms. So guys, if you want to keep some notes of what we're doing, especially if you're not confident, that's okay. We're just starting this stuff. But step one is always going to be combine like terms, which we cannot cross that center divide. So if you need to draw a dotted line on your paper, that might help you. So I combine 2 and -3, and what do I get? -1. So my left side is now 2x plus -1 equal to, do I have anything to combine over here? Nope. Anyone able to tell me what we're doing next, John?
Take the 2x away from the right side and the left side.
Yeah, so how I kind of say this is like, and a lot of times people tell you not to do this. Pick sides. What I mean is, guys, one of the sides is going to be our variable side. The other side will be the constant side. So John said, take 2x away from both sides, and that means there are no variables left over here. So the right side will now be our variable side. So -1 equal to 5x minus 2x, 3x plus 8, because I still have that plus 8. I'm still kind of on the pick side step, because now that my right side is the variable side, what do I need to get rid of over there? Vincent?
You should get rid of the 8.
Get rid of that 8, so we minus 8 from both sides. Be careful. -1 minus 8 more, or add a -8. What are we going to get on the left-hand side? -9 equal to 3x. So we picked sides and we did like add or subtract, right? Add or subtract. And then the final step here that we're still a little iffy on. Lucas? We divide to get just 1x. So our final step here, we divide to get to 1x. So, how do I turn 3x into 1x? Divide by 3. And a negative divided by a positive would stay negative. So like we talked about, x can be positive, x can be 0, x can be negative. Question. We're going to do a bunch of these today. So actually, if you have questions, you can ask it now, but we're going to practice this a lot today. That's why also keep this paper out. It has a few examples from class. If you didn't pick this up yet, because this stack still feels pretty thick, grab one of those if you did not pick that up yet. If you want algebra tiles, I'm not going to force anyone to use algebra tiles, but if you want them, grab some up here. And let's check 614. So I'm zoomed in a little bit far to try to make sure that you guys can see these things. But I can zoom out once we get down to those questions that really might need us to do that. Trying to find my 614 for when you guys have questions. So in A of 42, we end up shading left for less than 1. For B, we end up greater than or equal to. I'm not sure if I still have. So Amanda, you should have a copy of this. Remember, I made you your copies in Portuguese. Well, that was yesterday. Where is it today? We gotta get it all. You can have this one. Are there no extras over here? There might be in here. These are from previous years. Maybe not. So I don't know why I made 2 copies of this, but there's another copy for Portuguese. Questions. Layla. Sorry, which one? 42B. Oh, thank you so much. Because that's one that there's actually a less difficult, I don't want to say the E word, but there is a less difficult way to solve this. I need everybody paying attention to 42B. When we have 4/5 x is greater than or equal to 8. I'm actually going to copy it down so then I can use some other colors. This means that we have multiplied by 4 and divided by 5. Really, we could write this as 0.8, because that's what decimal, if I throw this in a calculator, that's 0.8. But here's the trick. To destroy any fraction coefficient, and this is not what you think I'm going to do. This is multiplication. So immediately you're like, oh, so we divide. Not when it's a fraction. When we have a fraction, the best, the easiest, easier, still not easy, but easier. How do I undo division by 5? Multiply by 5. Put it on top. How do I deal with a 4 on top and like cancel it out? Put a 4 on bottom. What that actually, now I'm going to have to do the same thing over here. So I'm going to write it down before I forget. What that's going to give us is 5 times 4 is 20. 4 times 5 is 20. What is 20 over 20? A grande uno. Math 8 renamed our giant one. They would like it to be called grande uno from now on. So what we really have is 1x. But then on the right side, a fraction is easier to deal with if they're both fractions. So I make my 8 into a fraction by putting it over 1. Guys, even if you already did this problem, writing it down this way is the easiest way to deal with the fractions. This becomes, well, 8 times 5 is 40. 1 times 4 is 4. 40 over 4. And I don't need to say 1x. I could just say x is greater than or equal to 10. And guys, this is where, if you need to grab graph paper to do work on it, I can't guarantee that you have enough space on this paper. Or guys, I am perfectly fine if you use Post-its. If you do work on a Post-it and stick it on your paper, you're like, yep, I ran out of space. That is 42B. Like, I would probably label it like 42B. Yeah. So, combine like terms, there are none. Right? Down the center, I would kind of have that fence. Again, here's my advice to you. Everyone put your eyes on the board for a second. You have positive 3x and negative, this is negative because the sign goes with it, negative 2x. The best way to deal with this, we don't like negativity. No one likes negative people. So we're going to add 2x to both sides. If you haven't done this yet, you should be doing it with me. We would now get 5x, still have that minus 3, less than 2. How do I get rid of a minus 3? Add 3. See, Mr. Hall is like as excited about math as me. We are both crazy math people. X is less than 5. And then you would want to graph those on your number lines. Oh, yeah. My bad. Good catch. You should see me after class because I will give you candy. So 5x is less than 5. And this is where you can also do this with your work. It's not as nice, but I can copy down here. 5x is less than 5. And then, how do we turn 5x into 1x? Divide by 5. X is less than 1. If you did not try these on your own last night, you owe it to yourself to try them on your own tonight. We're gonna have a quiz on Friday. I gotta check in with people and see who needs help at this point before we get too deep in this stuff. Okay, so we are having a quiz on Friday about solving equations. And probably graphing inequalities, right? How can I go graph this now? We put the boundary point. Put the boundary point, which here is 1. I barely have space to write it. We circle it. Is that going to get shaded in? No, because it's just less than. So we shade to the left and put an arrow at the end of our shading. X can be any number out there. In 43, you're testing, right? You're essentially testing in 43. I would try to make this inequality simpler before we test it, but wait a minute. That's very similar to this inequality up here. These are very similar, but they're not the same. So I would make that one, try to make that easier first. We could add 2x on both sides, and we could add 2. Like literally the constant 2. If we made this easier and did what I just said, we could get this down to 5x is less than 4. And then we can plug in these values and test it. Hint, you can plug them in and test. I should get rid of this word just. That's not a good word. That's almost like saying easy. All right, on the back, because that's pretty much everything from the front. So only A fails there. For 43, A fails. The rest are good. Check your perimeter on 45. In 46, sorry, Layla, what's up? So that wants us to replace z with 3. It's not a good arrow. Replace z with 3. Replace y with -5. And do this, right? So if I do this with replacing those things, I'm going to, again, use a Post-it because I'm not trying to write all over this paper. So if I make z 3, it's now 3 plus 2. Over y is -5, then plus 1. So I have to do this stuff first. This is what's confusing some people. This really is like we have parentheses on top. in a division problem, we have to solve the numerator if we can, and you have to solve the denominator if we can. So this becomes 5 divided by negative 5, because my numerator became 5. My denominator was negative 5. What is 5 divided by negative 5? Negative 1. And negative 1 plus 1? 0. I like that noise. It makes sense now. I heard the oh. It's the best noise. That and maybe the doorbell when your pizza shows up. Yeah, pretty good noise. Except I go get my pizza normally. There aren't enough delivery drivers right now. So first you find the perimeter expression, and then you plug in x to solve parts A and B. Right? First you find the perimeter expression. Then when x is 7, or when x is 5.5, we plug it in. 46, let's look at 46 together. 46 is one of those just like, we kind of observe what they did. If I call my number, my guess number, like x, what is this second column doing with the x? Yeah, it's timesing it by 2. So I can write 2 times x. What's the third column here doing? It's adding 2. My do column, remember how we talk about addition is sum? So a nice word problem we could create here. What sort of shape has 3 sides? A triangle. So what you could write out here is a triangle has an unknown side x, another side that is twice as long, and another side that is 2 longer than x. Its perimeter is 74. If you wanted to write out something like that. And for part B, we just did it, right? X, double X, 2 more than X. Hey, John, don't make me take that because I like those things, so I'll take it and keep it. So, like, put it away. We used to launch those things off my church balcony. See how far they would go? What word would we put above the do column? Well, I already did it. Sum. We added them up. And then our answers for 47. 1.5 gallons. 20 minutes. We can solve that using proportions or a couple different ways. Layla? Yeah, thank you for saying it like that. Guys, I'm really proud of those of you that are like asking really good questions, and I'm just waiting for some of the others of you to like, you know, be able to say, wait, I got different answers. Like, talk me through it. So 5 minutes and 1/4 of the way full. Guys, anytime I have 2 different labels, I'm thinking about like a proportion. But I also know the pool is going to hold 30 gallons. Amanda, you with me? You look bored. Because I don't think you have this done since your binder's not here. So if it's 1/4 full, what's 1/4 of 30? So I can do 30 divided by 4. Or you could do 1/4 of 30. 7.5 gallons is how full it is right now. So what I would probably set up is 5 minutes got 7.5 gallons. That's just my setup, though. I haven't solved anything. Assuming that the water is flowing at a constant rate means like consistent, right? Not a bunch 1 minute and a little the next minute. About how much water is going in the pool each minute. I'm actually going to go this direction. How do I go from 5 to 1? Divide by 5. So we do the same thing. And that gets 1.5 gallons. Gallons. Sometimes changing the emphasis on the word is fun. If you put the wrong emphasis on the wrong syllable, you can say it'll up your horse and gallop into the coral. If you put the wrong emphasis on the wrong syllable, you can saddle up your horse and gallop into the corral. But it can also be said, if you put the wrong emphasis on the wrong syllable, you can saddle up your horse and gallop into the coral. Yeah, if you've ever wanted a clip of Mr. Hudson might be losing his mind, there you go. At 20 minutes into class today. All right, how do we go from 7.5 gallons to 30 gallons? We'll just move on and forget that happened. Because we're going to fill the pool. If I don't know how to get here through multiplication, what do? Divide. So 30 divided by 7.5, that's times 4. So it's what I do to the numerator also. Times 4. Guys, I don't write out this work because I'm a teacher and that's like a teacher thing. I write out this work because that's how math is done. The people that are like, oh, I just did it in my head. Woo, let's throw you a parade. No one cares. I'm serious. No one cares when you say, oh, I can do that in my head. Because eventually you make a mistake because you did it in your head. Write out the work. No offense, I love you all. You're wonderful people, but I don't care if you can do it in your head. I need to see it. Vincent. Gosh dang it. Getting ready to preach at you guys about right now. Label. I did that on purpose. No, I did not do that on purpose. I did that to re-emphasize, put your labels on your numbers. So then when you make a mistake, people can catch you. Thank you very much, Vincent. You can also see me after class if you would like. All right, we need to move on and do some class stuff. This, if it's done, should be turned in. Make sure your name's on it. I had 4 no names from 1 class yesterday. Luckily, it wasn't you guys.
We would know if it was.
Well, I mean, 4 of you would probably be like, wait, was that me? And keep out 622, which I do not think I grabbed a copy of yet. Anyone, is magic still a thing? Do people still watch magic? So, this is probably where I started to get interested in math. There was this magician who was actually always masked. You couldn't see their face. And he would do these things where it's like, pick a number, and then get the corresponding letter of the alphabet, and then pick an animal, or like pick a country, pick a color. And it was always like, at the end, he was like, your gray elephant from Africa, da-da-da. And I'm like, whoa! Like, he knew, somehow, this dude on TV, like, knew what was in my head. And eventually I realized, oh, it's just all math. A lot of magic, sorry. A lot of magic is math. It's just, it happens so fast you don't realize it. So I got one of those things for you. So Chen's sister's like, I bet I can do a magic trick. Chen's like, I don't believe in magic. But his sister's like, nah, do this with me. So I'm thinking of a number. Okay, do we know what her number is? No, what would we call that? X. This is on your paper. This is on this. Sorry, I should have said that. This is on this. This is on your paper. So if we don't know the number, what do we call it? Most of the time we call it X. All right, so she's thinking of a number X. If you add 2 to the number, if we add 2 to the number, okay, let's everybody add 2 to the number. and then triple it. Oh, and then. So guys, I can't just triple x. I have to triple the whole x plus 2. How would I show tripling all of x plus 2? Layla? And Antonella already shouted it out. Say it louder. Parentheses, she says. So then triple it. I actually don't love red because I use that a lot for like attention grabbing. So I'll do that. You get 9. And Chen's like, okay, great. I can figure out what your number is. She's like, no, but it's magic. And Chen goes, no, it's math. Try this. At your table group, try to figure out what the number is. What is Chen's sister's number?
I'm all by myself.
Now, actually, even if you don't have algebra tiles, that's fine. But I'm going to build this with algebra tiles to make sure we understand what's going on. Get out of here, telemarketers. I'm waiting for my suit to be finished for a wedding, though, so I'm tempted to pick up those calls. If you have algebra tiles, you can go ahead and grab them. Whoa! Algebra tile explosion. So, x plus 2 is this the problem that we have? Do I have everything I need? Hint, I don't have everything I need. What do you, like, you should have this written down. What am I lacking? What am I missing? Oh, I need 3 sets of x plus 2. So I need another.
Wait, I think that's.
You mean the homework might be related to what we do in class? What?
Not this homework. I think yesterday's homework.
Wait, you mean I might have you try stuff on your own and then, like, reteach it to you? What?
I don't believe that. You win. So we pull out our homework and we have the answer.
So, my B, because I think a couple of you asked about it, 613 I still have because I haven't graded it yet. So if you turned in 613, I still have your 613. Okay? My bad. I know my brain's pinging all over the place. Now, do I have 3 sets of x plus 2? Yes. Do I have 9? Yes. If we put stuff together, what do I really have on the left side? Ooh, how many? 3x plus 6, because 3 times the x gave us 3x, and 3 sets of 2, what's 3 times 2? Gave us 6. Please draw those arrows on your paper. I've been begging you to draw those arrows like all year. Equal, is there anything to do on the right side? 9. Ha, it's the German word for no, except it's also the number. Never mind. So then, if we go back and look at the mat, what could I do on both sides? Whoa!
That's it easier.
I know, but man, you're judging me. You're like, wow, I'll take your easier way in a second, but Lucas, what can I do now?
You can get rid of 6.
Get rid of 6 from both sides.
And then you have that.
And then I have this. So what we would write on both sides is minus 6. And then we had 3x equals 3, and somebody told me what to do. How do I turn 3x into 1x? And x equals you can say, I feel like there's a better way. All right, so then on your paper, draw a little squiggly line down the middle. Hopefully you still got space on the right. John wants to flex on us that there's a better way. So hold up. I'm going to rewrite what I had. I had 3 times x plus 2 equal to 9. And I think this is where John wants me to go back to.
Yes. So, what you want to do is you want to start with the 9, and then subtract 2 from the 9. Wait. No, never mind. Okay. Start with the 9, divide by 3.
So hold up. This is what it looks like if I reset. I have 3 sets of x plus 2. John is saying divide by, I just need to kind of turn how this looks. I got 3, and I got 3. But what John is really saying is I can cover those up and just look at one of the sets. Because at the very beginning, instead of doing 3 times, guys, this is a different way. Not necessarily better. If it doesn't make sense to you, you don't have to take this way. But so, John, you said do what now?
After this, can I, do the way without the algebra tiles?
Sure, but I think what you're telling me to do, matches with the algebra tiles.
And then subtract by 2.
So I'm going to rewrite this now. So when I divide by 3, I just have one set. X plus 2 equals 3.
Then subtract 2.
So hold up. Pop back over here. What John is telling us to do is only look at one of the sets. Because it's all equal, right? It's all equal straight across. That equals 3, that equals 3, that equals 3. So I can just look at one of them. One of the sets is equal to 3. So now he said take 2 away. Do I get to the same answer?
Yep.
Yeah. You can. If you have multiple sets, like we have 3 sets of, you can divide first. You can split up your groups. But what if this was 10 instead of 9? Would this work as nice? No, not as nice. So sometimes it's a nicer way to go. Sometimes the distribution is the nicer way to go.
That has to be a multiplication.
Both of those ways work. What's next on your paper? Try 61 on your own, but try to do it both ways. Do one with the arrows and the distribution. Do the other dividing first. I'm going to build it just so we have somewhere that we can all visualize together. And I like building things. Two, 4, 6, 8. Who do we appreciate? Miss Martin. Yeah, Miss Martin.
My fiance is sing that song. Sometimes.
So I think what our paper says is 4 sets of x plus 3. 4 sets of x plus 3. Sorry, so I got all 4 sets of x plus 3 equal to 8. let's do the distribution first. So if I put all of these together, if I draw the arrows, so guys, it often helps to copy it down again, but then we should be drawing arrows to show that multiplication. What's 4 times x? 4x. And 4 times 3? Guys, trap door. The second multiplication is what people forget to do. So 4 times 3, 12 equals 8. Now, any volunteers for what I could do on both sides? Any new volunteers? Antonella? Or Amanda? Sure. Yeah. What would you do on both sides next? Yeah, get rid of the 12 minus that 12. Ooh. 8 minus 12. Careful here. What's 8 minus 12? Negative 4. So we have 4x equals, and I'm going to put it in parentheses because it's negative and that's just a little nicer. 4x equals negative 4. What do I do now to turn 4x into 1? I was about to say, Marina, real tempted to call on you since you're doing your hair back there. Divide by 4. Divide by 4.
I'm not saying that the process that I said was easier. I'm saying it's shorter.
Okay, yeah,
It's faster.
perfectly true. Now, faster, that's not the goal,
Oh, yeah.
right? Speed is not the goal. We are not speed racer here. So guys, let's do this on the mat, but watch what I do, because this is actually done on your paper. What John would have us do: divide everything by 4, and then we only have to look at one set. So when we divide by 4, what we now have is x plus 3 equals 2. Then, and guys, this is on your handout right here. Right here. I can't take away 3 from the right-hand side, right? There aren't 3 to take away. Quote, unquote. I can't. Yes, I can. But what's actually happening is I'm making 0, because I want these to disappear. So I bring in 3 negatives to make zeros. So I bring in 3 negatives, and I 0, 0, 0, 0, 0.
1x equals negative 1.
Now we get... So here's them doing that. So if you want to make a note, because we're almost out of time today. Here's that other way, taking the John route. Oh, come on, you are not focused. There you go. This is like minusing 3 from both sides. But if you were doing it with algebra tiles, we'd have to actually do 3 negatives. We end up with negative 1. That zeroes out. We get x equals negative 1. Sadly, that's all the time we have for today. I know you all want to do more math and hang out with me, but have a wonderful day. Please put your tiles away if you can.
Oh, yeah.
Please turn your homework in if you didn't. Really quickly, I need these people. Carmen, Isabella, we already talked, Jesus, and Vincent. Real quick. Man, there's a lot less from your class.